Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this couple of videos we are going to take a detour from pandas and talk about basic descriptive statistics. And the reason for this is that in coming videos, when we start using some of these statistical methods in the code, you'll be able to interpret what the output is, and you'll have an intuition about what's probably happening in the background when the code ran to give you that particular output. So here in this couple of videos, we're going to talk about all these topics that are put here on this slide, starting with what is population and sample in statistics, and then what is histogram, mean, standard deviation, all the way up to geometric mean and harmonic mean. So there's a lot of stuff in here, and I tried to make one video, but it was more than an hour, so I've broken that up into multiple videos, and in each of those videos you'll see parts of this being discussed. So I hope you learn from these videos. So let's get started. The previous topic, variance, we just had one parameter, which was battery life, right? Now in this particular case, what if we have two different independent variables, or two separate measurements of different items? So first thing that you measured, let's say, was battery life for the laptop, and while you were there you said, okay, why don't I go ahead and also note down the laptop age? So now you have two different variables there, battery life and the age of the laptop. So by looking at this, we can see that as the older laptops tend to have much less battery life, whereas newer laptops seem to have a higher battery life. So a 10-year-old laptop has only 11 minutes of battery life, and a 3-year-old laptop has around 55 minutes of battery life. So let's see if Covariance helps us identify this. If it were 1,000 data points which we could not visually see and make this particular inference from those observations. So to calculate variance, this could be just two, or it could be more than two variables. What we are going to is calculate the mean as we did before. So mean of battery life, mean of laptop age, and then subtracting each observation from their respective means, as we see here, 11 minus 35 for battery life and 10 minus 6.5 for the laptop age. Once we have that, we can go ahead and multiply those and add them up, and then divide that by n minus 1. This gives us the covariance. In this case, it is minus 54.3. Now, what the covariance tells us, the negative sign tells us, is the two variables that we measured, the battery life and the age of the laptop, are inversely related. And that's exactly what we saw in the very beginning. So covariance does tell us the direction in which these data sets are aligned. Is it a positive direction? If one increases, does the other one increase? Or is it a negative direction? But it does not tell us by how much or how strongly how strong that inverse relationship is. But this gives us an idea of only the variance or the covariance. The higher the covariance, usually you can think of it as there is more variability to the data set, and similar to the variance that we saw. Now let's look at a step further from covariance, how we can use correlation to add not only direction but also add a value that tells us how strongly those are moving in that direction. So there are three different types. We'll go through each of them one by one. The most commonly one that I've used is a Pearsons correlation, and that's what you'll also see it being taught in textbooks a lot. So again, we have these two data points, two parameters, and that 4 data points each: battery life and laptop age. Then as before, we take the difference of each observation from the mean, and in this case what we are going to do is we are going to square each of these together and also multiply these columns here. So as you can see, A, B are multiplied here, and then C represents square of A, D represents square of B. Then we take sum of all these 3 columns and put them here in this formula, and what we get as output is minus 0.95. Now correlation varies between 0, minus 1 and 1. Okay, so the negative sign indicates that there is an inverse relationship between those two variables. If one increases, the other one decreases, and the value closer it is to 0, it means the relationship is weak, and the closer it is to either minus 1 or plus 1, then the stronger that relationship is between those two variables. So in this case, 0.95 minus 0.95 is closer to minus 1, and therefore we can say that there is a very strong relationship between battery life and the age of the laptop. So the older laptops do seem to have much lower battery life as compared to newer laptops. So that's the takeaway message from this. Now in certain situations, the Pearsons correlation does not work, and in that case there are rank correlation that can be used. In this case, in this particular example, I've kept the previous example of laptop age, but which may not be appropriate here, but just to show you the method this would work. What we want to do in this case is rank the data set, rank all the observations. So highest rank is 55 and we give it rank of 1, and lowest is 11 and we give it rank of 4, and all the others fall in between. Similarly, we rank all the observations in the variable laptop age that go from 10 to 3. So 10 being the highest rank, 1, 3 being the lowest rank, which is 4, and then we take the difference between these two. So 4 minus 1 is 3, and we do that for all the other observations, and finally we are going to square the differences and take the sum right here. So 3 square of 3 is 9, and then we take a sum of that is 20, and then plug in those values in the equation or formula given below. So here the n is the number of observations, which is again 4 that we have. Now the correlation that we find by this method is minus 1.0. Again, it at least tells us that there is a strong negative correlation between the battery life and the age of the laptop, as we saw in the previous correlation with Pearsons. Similarly, there is a Kendall correlation coefficient. This also talks about the rank, and here the method is slightly different. We have two variables, and what we do is we sort one of them in ascending order and then take the other one to create data points for concordant and discordant columns. So in case of concordant, what we want to do is take this observation 10 and see how many observations below that particular row are greater than 10, and here it is 0, so we put a 0 there. Next we look at 8 and then look at all the rows below it to see how many observations are above 8 or greater than 8. It is 0, and we do that for remaining 2, and all of them are 0. For discordant, what we do is we take 10 and then look at how many observations below that row are less than 10, and here there are 3, so we put a 3 there. Again for 8, how many observations are less than 8? There are 2 of them, so we put a 2 there, and so on and so forth. We add values here, then we take a sum of those 2 and plug them in the formula below. Again we get a correlation coefficient which is minus 1.0. This tells us that there is a negative strong negative correlation between battery life and the age of the laptop, and it's an inverse relationship. Before moving on, I just want to share one of my experiences, that if you see a correlation of 1, you definitely want to go back and check your calculations to see if you have not made any mistakes, because it's very unlikely that you'll ever see a correlation of either plus or minus 1 in a real data set. But this sample data set, and we are able to see it here, so that's perfectly okay. That was it for this video. In next video we'll continue this discussion on statistics. Please like, share and subscribe. Thank you.